The average American household uses about 30 kilowatt hours of electricity per day. On a homestead, that number can be higher. Well, pumps, freezers, tools, lights, all running around the clock. And off-grid, you generate every single watt yourself. No utility company, no backup line, no safety net. If your system fails on a January night, you're sitting in the dark in the cold. Today, we're breaking down every off-grid power system, what it costs, what it actually powers, what can go wrong, and which combination makes sense for your homestead. Let's start with the one everybody knows. System 1, solar panels, the king of off-grid. Solar is the most common off-grid power source on Earth right now, and that's not because of marketing. It's because the math works. Photovoltaic panels convert sunlight into DC electricity. No moving parts, no fuel, no noise. You bolt them to your roof or mount them on the ground, point them at the sun, and they produce power for 25 to 30 years with virtually zero maintenance. The average off-grid homestead needs a 4 to 10 kilowatt system, which translates to roughly 15 to 30 panels depending on the wattage of each panel. Monocrystalline panels are the current standard, about 21% efficiency, best performance in direct sunlight. If you're in a cloudier climate, amorphous panels are worth considering. They're less efficient on sunny days but handle overcast conditions and indirect light significantly better. Cost for panels alone runs about $1.00 to $150 per watt. A 5 kilowatt array is roughly $5,000 to $7,500 just for the panels, but panels alone don't make a system. Once you add batteries, an inverter, charge controllers, wiring, and mounting hardware, a complete off-grid solar system runs $15,000 to $30,000 installed. You can cut that cost significantly by doing the installation yourself, but you need to know what you're doing, or you'll be troubleshooting wiring in a thunderstorm. The limitation is obvious. No sun, no power, nighttime, overcast days, winter months with short daylight hours. Solar alone needs a massive battery bank to carry you through, and that battery bank is often more expensive than the panels themselves. Solar handles the daytime. But what about when the sun goes down and the wind picks up? System 2. Wind turbines, the 24-hour supplement. Wind turbines generate electricity day and night, which makes them the natural partner for solar. When the sun sets and panels go dark, wind often picks up, especially in open elevated terrain. That's the theory. The reality is more complicated. A wind turbine uses blades to catch the wind, spin a rotor, and drive a generator. Two main types exist. Horizontal axis turbines, the classic propeller design you see on wind farms, are more efficient and more common. Vertical axis turbines look like egg beaters, catch wind from any direction, but produce less power per dollar. For a homestead, small residential turbines range from 400 watts to 3 kilowatts. To work properly, they need consistent wind speeds of at least 12 miles per hour. That means tall towers, 60 to 100 feet, with at least 200 feet of clearance from trees, buildings, and terrain features that create turbulence. Cost runs $3,000 to $8,000 for a small turbine plus tower installed. Here's where honesty matters. Small residential wind turbines are one of the most oversold products in the off-grid market. The numbers on the box assume ideal conditions that rarely exist in a real backyard. Many homesteaders report actual output is a fraction of what was advertised. Dollar for dollar, additional solar panels often beat a small wind turbine. Wind makes sense as a supplement in a solar-wind hybrid system, filling nighttime and winter gaps, but only if your site genuinely has strong, consistent wind. If you're not sure, put up an anemometer for 6 months before spending a cent on a turbine. Solar and wind both depend on weather. The next system doesn't care about weather at all. System 3. Micro hydro, the 24/7 powerhouse. If you have flowing water on your property with any amount of elevation drop, pay attention. Micro hydro is the single most underrated off-grid power source that exists. A micro hydro system uses a small turbine placed in a creek or stream. Water flows downhill through a pipe, hits the turbine, and generates electricity. Continuously, day and night, rain or shine, summer and winter. A small stream with just 2 to 3 feet of drop and 10 gallons per minute of flow can produce 500 to 1,500 watts of continuous power. That doesn't sound like much until you do the math. 500 watts running 24 hours a day is 12 kilowatt hours per day, enough to power a small homestead entirely. And because the output is constant, you need far less battery storage than solar or wind systems. The batteries are just buffering, not carrying you through the night. Low-head turbines work with as little as 5 to 10 feet of elevation change. Higher head, more drop, means more power from less water. Cost is remarkably low. A quality micro-hydro turbine runs $1,000 to $5,000. Installation is mostly piping and basic electrical work. Maintenance is minimal. Clear the intake of debris weekly. Inspect components quarterly. Per kilowatt hour produced, Microhydro is cheaper than solar, cheaper than wind, and more consistent than both. It is objectively the best off-grid power source available. The catch? You must have flowing water with elevation drop. No stream, no option. And water rights laws in many states may restrict what you can legally divert. Maybe 1 in 10 properties can actually use microhydro, but if yours is one of them, build this first and everything else becomes supplemental. Microhydro, solar, and wind are all renewable. The next system burns fuel, and every off-grid homestead should have one anyway. System 4. Generators, the necessary backup. Nobody goes off-grid dreaming about a generator. But every experienced off-grid homesteader has one, because there will be a week in January when it's overcast, calm, and your batteries are dropping. That's when a generator saves you. A generator is a fuel-burning engine that produces electricity on demand. Gas, propane, or diesel, flip the switch, power flows. For off-grid use, propane generators are generally preferred over gasoline. Propane stores indefinitely without degrading. Gasoline goes stale in a few months and requires stabilizer. A 500-gallon propane tank can keep a backup generator running for weeks to months depending on usage. Dual fuel models that run on both gas and propane give you maximum flexibility. Portable generators in the 2,000 to 3,500 watt range cost $500 to $200. Whole house standby generators running 5,000 to 10,000 or more watts cost $2,000 to $5,000 or more. The role of a generator in an off-grid system is specific. It's not your primary power source. Running a generator full-time is expensive, noisy, and defeats the purpose of going off-grid. Its job is to recharge your battery bank during extended periods when solar and wind can't keep up, to handle heavy startup loads like well pumps that spike beyond what your inverter can deliver, and to serve as your emergency fallback when something in the main system breaks. Think of it as insurance. You hope you never need it, but when you do, nothing else will save you at 2 a.m. in a snowstorm. Generators burn fuel you buy. The next two systems burn fuel that grows on your property. System 5. Wood gasification, the forgotten technology. This is the off-grid power system that almost nobody talks about, and it has a fascinating history. Wood gasification superheats wood in an oxygen-limited environment. The wood doesn't burn. It breaks down into a combustible gas called syngas, a mix of hydrogen, methane, and carbon monoxide. That gas is then cooled, filtered, and used as fuel to power a standard combustion engine generator. The technology dates back to the 1800s. During World War II, when gasoline was rationed across Europe, an estimated 9 million vehicles ran on wood gas. Cars, trucks, buses, tractors, all powered by wood chunks fed into gasifier units bolted to the vehicle. When gasoline became available again, the technology was abandoned and largely forgotten. For homesteaders, wood gasification means true fuel independence. If you have forest or timber on your property, your fuel supply is renewable and free. Roughly 2.5 pounds of wood produces 1 kilowatt-hour of electricity. A 10-kilowatt propane generator running on syngas will produce about 6 kilowatts. Syngas has about 50 to 60% of the energy density of propane. Modern gasifier systems range from $2,000 to $20,000 depending on capacity and build quality. DIY builds are possible from standard plumbing parts for a few $100s, but the learning curve is steep and the margin for error is real. The downside: wood gasification is not hands-off. You're feeding wood, managing the reactor, filtering gas, and monitoring the engine. It's labor-intensive compared to flipping a solar switch, but for homesteads sitting on 20 acres of timber with no desire to ever buy fuel again, gasification is a genuinely viable path to total energy independence. Wood gasification uses trees. The next system uses what comes out of your animals. System 6. Biogas, power from waste. If you have livestock on your homestead, you already have a fuel source. You're just not using it yet. A biogas digester is a sealed chamber that breaks down organic waste, animal manure, food scraps, garden waste, through anaerobic digestion. Bacteria consume the organic material in the absence of oxygen and produce methane gas as a byproduct. That methane can be burned for cooking, heating, or small-scale electricity generation. A medium-sized home digester processing waste from 2 to 3 livestock animals produces roughly 1 to 2 kilowatt-hours per day, plus 2 to 3 hours of cooking gas. The system needs about 20 to 30 pounds of organic waste fed into it weekly to maintain consistent output. The byproduct is a nutrient-rich liquid fertilizer, making this a true closed-loop system where animal waste becomes energy and the leftovers feed your garden. The bacteria that drive biogas production work best above 68 degrees. In cold climates, the digester needs insulation or underground installation to maintain temperature, which adds complexity and cost. A basic home biogas system runs $500 to $700. It's not going to power your house, but it can replace propane for cooking entirely, which over years adds up to real savings. Biogas is best thought of as a bonus system, not a primary power source, but a smart way to turn a waste management problem into free cooking fuel. If you have animals, there's almost no reason not to explore it. Those are the generation systems. But generating power is only half the equation. Without storage, every watt you don't use the moment it's generated is wasted. System 7. Battery storage. The heart of every off-grid system. This is the component that makes or breaks your entire off-grid setup. You can have $30,000 worth of solar panels on your roof, but without a properly sized battery bank, you have no power after sunset. Batteries store the electricity generated by your panels, turbines, or hydro system during peak production and release it when generation drops, at night, during cloudy weather, or in calm conditions. Two main battery technologies dominate the off-grid market right now. Lead-acid batteries, the traditional option. Flooded and AGM variants run $150 to $300 per battery. Cheaper upfront, but limited. You should never drain them below 50%, meaning half your capacity is unusable reserve. Lifespan is 3 to 5 years. Flooded types require regular water topping and ventilation. Lithium iron phosphate batteries, LiFePO4, are the modern standard. They cost more upfront, $500 to $2,500 per battery, but the advantages are significant. You can safely discharge them to 80 to 90%, which means you get nearly double the usable capacity compared to lead acid. Lifespan is 10 to 15 years, no maintenance, no gas venting. Lighter weight. Over a 15-year span, lithium is actually cheaper per kilowatt-hour stored because you replace lead-acid batteries 3 to 4 times in the same period. Sizing your battery bank requires simple math. But first, understand this. That 30 kilowatt-hour daily average from the cold open is a grid-connected household running air conditioning, electric dryers, and every convenience without thinking twice. True off-grid homesteads don't operate that way. You switch to propane for heating and cooking, use hyper-efficient appliances, and cut every phantom load. Most well-designed off-grid homes run on 5 to 15 kilowatt-hours per day. Multiply your actual daily usage by the number of backup days you want, and add a buffer. At that range, most off-grid homes need a 10 to 20 kilowatt-hour battery bank. Cost for a full lithium bank at that size, $5,000 to $15,000 or more. The battery bank is often the single most expensive part of an off-grid system. More than the panels, more than the turbine, more than the inverter. It's also the part most beginners undersize. Don't make that mistake. Batteries store DC power. Your house runs on AC. One more component connects everything. System 8. Inverters and charge controllers. The brain. These two devices are the nervous system of your off-grid setup. Without them, nothing works properly. The charge controller sits between your power source, solar panels, wind turbine, and your battery bank. Its job is to regulate the voltage and current flowing into the batteries, preventing overcharging and ensuring efficient energy transfer. Two types exist. PWM controllers are basic and cheap, $30 to $100. They work, but they waste energy. MPPT controllers are smarter. They actively optimize the voltage to squeeze up to 30% more usable power from the same panels. They cost $100 to $500. For any system larger than a single panel, MPPT is worth every dollar. The inverter converts DC battery power into AC household power. The 110-volt or 220-volt electricity that your lights, appliances, and outlets run on. This is the component where cutting corners hurts the most. There are two types. Modified sine wave inverters are cheaper but produce a rough electrical signal that causes buzzing in audio equipment, can overheat sensitive electronics, and shortens the life of anything with a motor. Pure sine wave inverters produce clean power identical to what comes from the grid. Every off-grid home should use a pure sine wave inverter, period. Quality pure sine wave inverters run $500 to $3,000 depending on capacity. Match the inverter size to your peak load. If you're running a well pump, power tools, and kitchen appliances, you need enough headroom to handle them simultaneously. A $30,000 solar array with a cheap modified sine wave inverter is a $30,000 mistake. The decision framework. How to choose 8 systems. Here's how they fit together. If you're in a sunny climate, solar as your primary source. If you have open, elevated land with consistent wind, add a wind turbine as a supplement. If you have flowing water with any elevation drop, microhydro first, everything else becomes backup. If you have abundant forest, wood gasification for true fuel independence. If you have livestock, biogas for free cooking fuel. Every off-grid system needs 3 things: a generation source, battery storage, and an inverter. And every off-grid system needs a generator as backup. No exceptions. Solar plus batteries plus a propane generator is the minimum viable setup for most homesteads. The universal rule: never rely on a single source. Layer 2 or 3 generation methods. Solar plus wind, solar plus microhydro. Redundancy is what separates a comfortable homestead from an emergency. Size your battery bank for your actual daily usage, plus at least 2 days of backup. Buy an MPPT charge controller. Buy a pure sine wave inverter. And start with an honest assessment of how much power you actually need. Reducing your consumption is always cheaper than increasing your generation. That's every off-grid homestead power system explained.